Hey, and welcome back to the Chromeworks studio in beautiful Ottawa, Canada. I'm Andrew Tomec, your technology teacher, and I'm here again with another great coding lesson for you. So we are working on part 3 of our RPG lesson. So this is the middle of a very, very big omnibus coding lesson that we're doing here, where we're going to be teaching you how to build an RPG game from the ground up. Jeffrey, my son, who's done most of the coding on this, has done a fantastic job of creating a system where that's expandable, so that you can take all of these lessons you've learned here and adapt them to your own video games. Last week we created a animation system that would allow you to take any animated character and have them switch back and forth between the animations without having to specifically code any of them. All you have to do is name things properly, and your animations will all move from one cycle to the next based on your commands, and you won't have to do any additional coding. It's really quite cool. Today we're going to add a very elaborate map system that's going to allow you to build a grid of maps that are interconnected with each other, so that your character can move from one map to another, gathering things, etc. And it's all, again, based on the name of the costume inside your background. And what's really cool about this is you're going to be able to very quickly just set up new maps and add elements to them, again, without having to do a lot of extra coding. All you have to do is set some parameters, like what the limits are of your room, what areas you're allowed to move in and what you're not, what monsters are going to be there, and then the rest of the coding is all handled automatically by some processes that are going to happen in the background. I'll get into all those details, but first let's have a look at what we finished in parts 1 and 2. So I've given you all, you can find a link in the video description. I've given you a file that's, I'm calling a catch-up file, that basically has all the coding that we did in parts 1 and 2. We're going to have to remove some of that coding because there's some stuff that we don't need anymore, that we put in temporarily to get parts 1 and 2 working. And then we're going to keep adding to that. Now, if you were coding along with me in parts 1 and 2, I'd recommend you don't use the file that you were actually building there. You're going to have to abandon that and start from the beginning again, because I've got some extra blocks in here, like this arrow graphic here, for example. Now, you could just design these yourself, I guess, if you wanted to keep building from there. And I've also, a little bit too small here. There, I'm at 100%. And there's a blank element here called the game controller. So if you are working from your last element, you're going to have to come up with a system of arrows, and those are going to be at the edge of the screen, basically telling you whether you're allowed to walk off the right or the left or the bottom or the top side of the screen. So I've got those graphics in the file here along with all that code that you've already done. So our game's working pretty nicely from last week. As you can see, our players spawning, attacking bad guys. Right now we just have skeletons appearing every couple of seconds and they attack us. You can see us reacting when we get hit, and we have 3 hit points, and then we drop dead if we get hit 3 times. Okay, so far so good. So we're going to start by programming an invisible object here called the game controller. And what that's going to do is basically keep track of which map we're on and what the limits are on that map. And it's going to also keep track of some other background stuff, like the music that's going on in the background. And so really controlling the background of our projects, what it looks like and what it sounds like. And that's all just going to happen in the background with this particular sprite here. So it's already in your starter file here. It's called game controller. I've already given you some blocks. There's some stuff in here that just would be too time consuming for you guys to do. If you're interested, you can freeze the video here and you can create this yourself if you want to, but because this custom block that I created here is used down below here, we have a different one for each map with all the different boundaries that we're going to use for these maps. And rather than having you input this stuff by yourselves, I thought I'd give you guys this stuff and save you the trouble. So if you do need this information, you can also download the documentation and it's all there. But I've created a custom map, a custom block here that's basically called reset map. And what it's going to do is basically set up these map limits. The farthest left you can go on the screen, the farthest right you can go on the screen, the farthest up and down that you can go on the screen, and the number of bad guys who are on the screen. We're probably going to modify this later on and add some extra monsters at some point, but at this point, that's all that we're happening is we're just going to define what those are. So for each level, when we land on that level, we're going to assess the name of the map and the, let me go to the backgrounds here and show you. So each map has a set of numbers after it, 1 by 0, 1/0, and these are kind of X, Y coordinates. So 0, 0, your Savannah map, is the starting map that you're going to appear on. When you go to the right, your X coordinate is going to change by 1, so the map name is going to change to 1x0. So that means 1 to the right. This one here, 2x0 is to the right of that. And then you've got some other ones here that have different Y coordinates as well. So here's one called 2x1. And so that is up 1 and over 2, so above the castle level. And so you can continue to build levels that way just by naming them differently. And our system that I'm going to show you in a couple of minutes is going to automatically place those so that the arrows will know. So you won't have to customize a different set of arrows for each level saying this is what's going to happen when you go up and this is what's going to happen when you go right. It'll keep looking at this grid system and figure out where you can go and where you can't go based on the naming of these backgrounds. It's a really clever system, and if you bear with me, I think you'll start to understand it. So we have to start coding this game controller to make everything start working. As I said, I've got the initial stuff done for you. There's also a block of code here that's quite complicated that I didn't want to have you guys rebuild because it's a whole bunch of text joins all one inside another one. Notice there's no starter block on the top. That's because we're not actually going to invoke this. It's not part of the game. What this system does is it looks at all the costumes and all the backgrounds and generates a list. Let me show you the list. Oh, sorry, cancel that. Here's my list called all backgrounds, and you can see it appear here. So it's actually just a list of all the backgrounds available and where they are. So the first background is your middle one, and then your one to the right, for example. And so it's taking those names and harvesting them from the file name and putting them to a list here. And this list is going to help the code figure out which map we're on at any given time. Let me hide that again. So what happens is, actually, I do want to show you one thing here. So I'm just going to delete all the objects on this list right now just to show you how this script we're going to run is going to delete them. So, I don't think I can delete from here. I'm going to have to do it this way. There's some things you're just not allowed to do while viewing the file this way. Yeah, here we go, X. So I'm going to X out all the data in this list. And so when you're creating new maps, every time you create new maps for your new RPG that you're building using this, you just run this code again by clicking on it. And what it does is it actually goes through, I think I stopped it too early there by clicking on it twice. So let me try that one more time. So we just click on it once, and it starts going through your code, looking at all the different backgrounds, cycling through them, and naming them all properly. So now we have a total database of 10 different maps that are available to us. And so anytime you make changes to your backdrops to add or subtract levels, you have to run this code basically to create a new list for you. And that's how that is going to work. So it's something as a game designer that you're going to use, but the actual player won't be using this, or the code won't be activated during the making of the game. It'll just happen while you're building code. It's an interesting little way to run this, and I haven't seen anything like this in Scratch before. So kudos to Jeffrey for coming up with a really creative system. Okay, so there's a whole bunch of code here already. As I said, you can grab this from my catch-up file and get caught up to where we are right now. Just a little bit of code to add here, and let's get on to that now. So We're going to start with a green flag here. Let's go to our green flags. I'm going to go when, green flag, click. Let's magnify a little bit. All right, so let's switch to the default backdrop, which is the first one. So let's just go tell it, and this is the only costume change that we're going to have to do that's defined. The rest of them are all going to be figured out based on which how we exit the level, right? So let's switch backdrop to the one called Savannah, which is the one that's called 00. That's the central one at the beginning of our map. And we're going to set a variable called mapx and mapy that's going to tell us which of these coordinates we're on. So we're going to set mapx to 0 and mapy to 0, and that's going to position us within this invisible grid of maps that we're creating here. It's going to tell us that we're on the very first of these maps. So let's go ahead and set variable in our variables list here. Ooh, my computer's running very slow today. Not sure what's going on with that. Okay, so let's go set variable mapx to 0, and we'll set mapy to 0 as well. I'm going to pause for a second here and see what's going on with my system. Obviously something's messed up. All right, I've done a quick reboot and things seem to be working much more smoothly now. So we've just finished up setting up the initial map coordinates here and begun setting up our grid system for our maps. There's a couple of other things that are going to happen in this game controller that all have to do with initializing things when our map starts. So firstly, we want to center this invisible object, the game controller, right in the middle, not in the middle of the screen, but in the middle of the playable area. So each map is going to have a playable area defined, and that's what we've done with the map edge, left, top, bottom, and right? It's defining an area where you're allowed to walk. So if I try to make my guy walk up here into the sky, he's not going to be able to do it. So we want the controller to be right in the middle of whatever the playable area is here so that we can spawn things a certain distance away from it and facing in the right direction. So at the beginning of every level, we're going to recenter that guy, and that's just a little bit of math. So the event that's going to trigger this is when I receive map changed, and that's what's going to be triggered every time we go to a new level. So we're going to go to a new XY coordinate here, go to XY, and we're going to fill that up with a little bit of math here. So we're going to take the leftmost map coordinate and add it to the rightmost math coordinate and then divide it by 2. And those of you who are math geniuses will know we're actually finding the average. So the spot halfway in between those two coordinates. So let's go ahead and grab some variable bubbles and we'll attach them with a plus. So let's go grab a plus sign out of our operators here. Plus. So I'm going to say map left, map limit left, plus map limit right. And then we're going to divide the output of that by 2. And so that's going to calculate a spot exactly in between the leftmost and rightmost edge of the playing field here. And that's what our left coordinate is going to be. Now let's just duplicate that whole thing. I'm just going to go duplicate here, and I'm going to pop that into the right window. Whoops. Let's try that one more time. I think I messed that up. There we go. But we want to fill this up with, since this is Y coordinates, we want this to be the upper and lower coordinates. So map limit up and map limit down. Let's grab those and pop them in there. Map limit down and map limit up. There we go. Okay, so now we've found the middle of the map, and that's going to happen every time that we do a map changed event. Let's do another map changed event, and this one's going to control the music in the game. So we've got a background music track here. It's in the control. Oh, I thought it was in the controller. Let me load it up quickly right now. I grabbed it off of the Free Sound website. It's called Anime Fight by Circoto51. I'll play it for you. So I'm going to give it a plug for Free Sound, which is the website that I use for most of my sound effects. It's free, no subscription fee at all, and it's got a million great sound effects and music stuff for all your projects. It's a fantastic site. So where are we? So we're back in the game controller here again. We've loaded the music up, and so now we're going to do an event that's going to launch that music off. When I receive map changed, we're going to start the sound, which is going to start it playing, of course. Start sound, anime fight. And then we're going to have it fade in. So at the beginning, we're going to set our volume to 0. And then we're going to have it slowly go up, so fade up. Now we're going to put that inside a repeat until event. This is a little bit of a coding trick here. What we're going to do is we're going to go repeat until enemy count is less than 1. So let's grab a less than sign, put a 1 in there, and enemy count is less than 1. So this little bit of script is quite clever because it's going to do 2 different things for us. It's going to increase the volume until we hit 100%, and it's just going to sit there waiting for us for all the enemies to be killed off. When our enemy count is less than 1, then we can fade out again. So this is going to control the music, make it play at maximum. So it'll get louder, play at maximum until you've defeated all the enemies, and then it's going to fade back out again. And the cool thing about this is if there's no enemies on the map, you won't hear combat music. So it's a really interesting way to control a whole bunch of stuff all at once, whether the music's playing at all and how long the music's playing, all by keeping track of this enemy count here. So let's change our volume here. Let's go to our sound, and we'll change volume by 10. So it's just going to get steadily louder when the map changes to a new one, and until we kill off our last bad guy. And then let's make it go down. So let's go to our, let's grab a repeat loop here. We're going to repeat 80 times here, which is a bit weird. But so to get down to 0 from there, we actually have to change the volume by minus 1.25. Now that's a little bit complicated. We could repeat 100 times and change it by 1. I'm not quite sure why we did it that way, but I'm going to leave it this way because this is the way Jeffrey programmed it. Change volume by minus 1.25. Again, using some complex math here. All right, so let's go ahead and test that. We're not going to be able to change levels, and we're not going to be able to actually end the music right now because we just have a continuous stream of monsters coming in the way this is set up right now. We'll have that fixed by the end of this episode, but let's just listen to what the music sounds like and how it fades in as our monsters appear. There we go. And it's looking good. And as I said, it won't actually fade out when we're done because the enemies are just coming fast and furious here. Let's just stop this. Okay, so we're ready to start coding the next part. Please ignore this. Project could not save. This is something that seems to happen a lot with Scratch, and I'm not quite sure what it's all about. But every once in a while we get into a situation where their servers are having trouble or something, and we keep getting this message. It won't stop us from doing anything, but if we do somehow crash at some point during this, our work isn't going to be saved, which is very unfortunate. You can always download the file to back up what you've done, but that won't actually, that's something you have to keep doing over and over again, which is really frustrating, and it won't make this annoying window disappear. So we're just going to ignore it for now, and I think that's the best thing to do. At the end of our coding session, if it hasn't disappeared, I'll just download the file and re-upload it, and we'll be good as gold again. Okay, so we're going to go over to the arrows. So the arrows are really what's going to control our movement from one map to the next. They're going to be invisible at the start of the game, and then when you kill all the enemies off on a level, they're going to appear, but in a very specific way. They're only going to appear if there's an available map following that arrow. So if there's no room above us, there won't be an up arrow appearing after we've killed our last enemy, for example. And when we walk up to that arrow and then press the letter E key, it's going to shift us over to that next map, and any enemies that are on that map will appear. We can fight them, and then when we disappear, the music will fade out and the arrows will reappear again. And that's kind of the workflow of this game and how it's going to work. Okay, so let's start coding here. So we're in the arrows. There's 5 different costumes here, just the arrows facing in different directions. And there's a last blank costume here, which is where our code starts. So just leave it there at the beginning. Let's grab a green flag and magnify. All right. So we do want that costume called costume 1 to be the first costume, and I've already manually set it to that, but let's actually place that command block there to make sure that change happens. Okay, and so what we're going to do is make 4 clones of our arrow. Right now the arrow is invisible at the, I think at the middle of the screen. Oh, it doesn't have a costume, so we can't even see it. Let's put a costume on it. Yeah, it's pretty much in the middle of the screen here. But we're going to tell it to disperse itself to the corners of the screen in a second. So let's go. Now we're going to create 4 different clones, and each one of them is going to have different attributes. We've created some variables here that are local variables, meaning that each clone is going to have its own set of variables, and that those variables that are going to load into it every level are going to be which level do I go to if I am touching that arrow. Okay, it'll make more sense as we go on here. So let's go to our variables. We'll go set arrow direction to 1. So this will be our first arrow, and then we'll create a clone of ourselves. So that first arrow will have an attribute of arrow direction of 1, and then that's how the software will know which arrow was which because of that particular arrow direction variable. Okay, then we're going to change that variable by 1. So let's go to our variables, change arrow direction by 1. So now our next one that we create here is going to be number 2, because it's going to change itself by 1. Now we can just go ahead and duplicate these 2 blocks 2 more times, because we're going to make 4 clones in total. There we go. So now we have our arrow direction. So each arrow is numbered 1, 2, 3, or 4. Excellent. Okay, now what are these clones going to do when they're created? Let's go when I started the clone. First thing they want to do is go to the back layer. They want to be behind the monsters and behind our good guys and basically behind everything else except for the background. And so we can move it to the back. Nothing can go behind the backdrop. So even if we move things to the back, that still will be in front of the background. So go to back layer, switch costume to looks. Let's go to our switch costume. Switch costume. Oh, I just flipped my backdrop there by accident. Let's just set that back again to Savannah. All right, back to our arrows. So we're going to switch costume to whichever costume matches our arrow direction. So let's go to our variables, grab the one that says arrow direction. And so if arrow direction is 2, for example, it'll go to costume 2. It'll be the left one. If arrow direction is 3, it'll be that one. And that's how the clones of the costumes will know which costume to wear. Okay, there we go. And they're invisible. So when they started the clone, we're going to have them show. And that's going to be at the beginning, but then as soon as the map changes, they're going to hide again, basically. So if there's any ways to go at the beginning of the game, this will go when I started the clone. But now we're going to hide it right away again. So we need another when I receive map changed command here, which is under events. When I receive map changed, you're going to hide these arrows. Looks, hide arrow. And we're just going to wait a little bit for the level to end and give us a little bit of a pause before they appear. So just a half a second. Wait 0.5. And now that's the minimum time we have to wait, but we're also going to continue waiting until all the bad guys are killed before the arrow appears. So on a level where there's no bad guys, it'll be half a second before they appear, and on a level with bad guys, it'll be basically until the last bad guy's killed and then an additional half second. So let's go wait until, which is under our control blocks here. Wait until enemy count is less than 1. So let's go grab a less than sign, less than 1, and we'll go to our variables and go enemy count. So wait until all the bad guys are dead, and then we're going to program these arrows to actually tell our player which map to go to. And that's all going to be done through a little subroutine that we're going to call here a custom block that's called get map goal. Let's create that right now. It doesn't have any parameters, so we're basically ready to go with this. All right, get define, get map goal. We'll put this beside. We have some more code to do down here, but we'll return to this in a minute. So let's go to get map goal, and let's start coding that. So what this is going to do is tell each arrow which new map it's going to go to if we click on it. So let's grab an if statement. So we're going to say if arrow direction equals 1, which is our first arrow, which is the right-facing one, right? So we'll go if, oh, I already have that there, sorry, if arrow direction equals, there we go, and arrow direction is one of our variables. If arrow direction equals 1, which means we have a right-hand facing thing, we're going to set the variable called map goal x. So we're going to set map goal x. And so this is going to set the x coordinate of the map. Now, this isn't the x coordinate on the map. This is the x coordinate of the giant grid that we created, remember, with our different maps on it. So this current map we're on is 0, 0. So if I touch the right map, it should go to 1, 0, or 1x 0. And so this is going to where we're going to change that. So if I'm going to the right, I'm going to go to map x, which is, so if this is 0, then it's going to be map x plus 1. So let's go grab a plus sign. To map x plus 1. So let's grab our variable called map x plus 1. So I hope you see what's going on here. It's basically determining which map am I going to, and it's going to be, if we're on the starting map here, which is an x of 0, and we go to the right one, the x is going to change by 1. So our new map coordinate is going to be 1x0, which if we look at our backdrop map, means 1x0 is a desert. So that means we're going to go to the desert when we click on the right-hand arrow when it appears. Can't test that yet, but just so you kind of get the general idea. Okay, and our y, let's go ahead and set that. We're going to go duplicate, and we'll say set map goal y to map y, map goal, or map y. So the current map coordinate that we're on, we're not moving up or down though, we're moving to the right, so we can add 0 to that. Now this block of code is basically going to do nothing, but the nice thing about setting this up this way is we can go ahead and duplicate this entire block and have the same structure for each one and just change a few numbers around. So just for the sake of simplicity, we're gonna put x and y coordinates in each one whether we need them or not. So let's go ahead and duplicate that whole block of code, and we're going to say if our arrow direction is equal to 2, which is the left-facing arrow, then we're going to change our x by -1. So our map coordinate is going to be -1, 0, and the bottom one's not going to change again. Okay, let's duplicate one more time. If our arrow direction is equal to 3, which is our down arrow, now we don't want our x coordinate changing at all, so we'll make that 0, and we'll change our map coordinate by -1. I think you guys are getting it by now. Let's go ahead and do the fourth one. 4, and this one is going to be 0 and +1. Okay, so I think you guys understand what this function is doing. It's just giving, it's basically saying when I click on this arrow, go to map coordinates 0x1 or 1x0 or 1x1. Basically, we're going to the map that matches these numbers here. So this is how these arrows will know where to send us when we go there. Okay, so let's go back to our main function again, and we'll keep adding to that. So let's go back to our arrow. And so after our enemies are done, we'll call that new function, get map goal. Let's plunk it right down there after our enemy count is 0. Now we're going to grab an if statement, control if. All right, the next little bit of code that we're going to do here is going to determine whether the arrow is visible or not. So we're not going to have an up-facing arrow appear on the map if we can't move up, if there's no connecting map above us. So what we're going to do now is check and see whether the map coordinate that we would go to with the up arrow actually exists or not. And if it exists, we're going to show it. Otherwise, we're going to leave it hidden. So the arrow will still go to the right spot, and it'll have the right coordinates as if there were a room there, but it'll be invisible and you won't be able to interact with it. So, so the list of backgrounds we have here is under our list variables here. It's called all backgrounds. So we're going to say if all backgrounds contains. So we're going to go right down towards the bottom here, and we're going to see if it contains a text string. And the text string is going to be that number 0x0 or whatever it is, the number is for that map. So let's go ahead and put together that string of numbers. I'm just going to create a little bit more space here. And we'll go join. We actually need to join 3 things together. So we need join apple and banana, and we're going to join another apple and banana, and that gives us 3 slots to add stuff to. So we're going to go map goal x, which is the x coordinate of our new map that that arrow will lead to, map goal x, and then an x, a literal x in the middle, and then a map goal y, map goal y. So basically, if like the right hand one, 1x0, if 1x0 exists, then show. Otherwise, we'll hide that arrow. Let's go show here. Good. Okay, so now we're going to tell the arrows where to go on the screen. We don't want them actually in the middle of the screen because, as I said, the playable area in these screens is going to be less than the entire size of the map. So we want each arrow to appear in the middle of the playable area. So we're going to do a little bit of math to tell it to appear, if necessary, to appear in the proper space. So let's go grab another if statement here. We're going to say if arrow direction equals 1. So this is what we're going to do for the right hand arrow. And let's go grab arrow direction. So if it's a right facing arrow, then we're going to go to an x coordinate. Well, let's go to an xy coordinate. Go to xy. So the x coordinate is going to be the map right hand limit, basically as far to the right as you're allowed to go on the screen. And we're going to make it appear there. So let's go grab that variable and drop it in there, map limit right. And the y coordinate, we want it to be halfway between the upper and the lower limit. So we're again going to do a bit of math here. We're going to divide by 2. So let's go grab a division symbol, and we'll go divided by 2. And inside there, we're going to say map limit up plus map limit down. So let's grab an a plus sign here, and we'll go to our variables and grab map limit up and map limit down. So I think you guys understand what's going on here. We're basically telling the arrow to appear as far to the right as the player is allowed to go on the screen, and halfway up between the topmost and the bottommost movable parts of the level. Okay, so we have to do that for all 4 directions. We're going to do a bunch of duplicating with some minor changes here. So if arrow direction is equal to 2, we're going to set our left map limit, and we're going to set it to the same. Actually, this part doesn't change at all here. Let's go duplicate again. Arrow direction 3. Now, of course, we're going to do this math. So let's flip this around here. We're going to put the map limit up, down, under. So we're going to put the plus sign on the right-hand side. Oh, I've messed this up now. Okay, let's just reconstruct this from the beginning here. So the left side is going to be map limit left plus map limit right. So map limit left plus map limit right divided by 2. Let's drag that into the leftmost hole. All right, so it's going to be halfway between the left and the right-hand side of the screen. This is going to be our up arrow, right? And then the bottom is going to be map limit down. Oh, this is the down arrow. That's right. Okay, and let's do it again for the 4th one, which is the up arrow, I believe. And we're going to go to the same thing here for the left-hand side, and the right-hand side is going to be map limit up. Okay, So this is going to make our arrows appear and send us to the proper level. Now, there's still one or two more things that have to be done before we can test this out. So just bear with me, guys. This is one of these levels where we don't see a lot of immediate results because there's a lot of things that are all tied into each other. So there's not much to test yet. Let's go over to our player. And there's just a little bit of code that we actually have to get rid of. So in our player, last week, we initially set up map limits here. Can I show them to you? So I set this up here last week. It said map limit up is 0, down. So this is the dimension of that first map. We hadn't set up this coordinate system yet that we set up inside the game controller. So that's why we have this set up here. So we can just go ahead and delete this here now. And there's one other little bit of code we have to add on this level, and I'm just going to find it right now. Here it is. All right. And this is just another map changed event. So let's go to our events, say when I receive map changed. We're going to point our player. What we're going to do is basically send him to the proper side of the map and point him in the right direction when he restarts again. So we're going to go motion point towards game controller. Point towards game controller. And so remember, the game controller is at the middle of the screen. That means that if we teleport here, he'll point to the right, and if we teleport here, he'll point to the left. Now he's in the spawner is in the middle, right? So one of the things we're going to do here, depending on what direction he's moving, we want to move him right off the screen here. So he gets points in the middle, points in the right direction, and then we push him off the screen. Now, just in case he's somewhere else on the screen, we're going to make sure he gets right off the screen by moving him too far. And this is something Jeffrey likes to do. We're just going to tell him move 500 steps. And that means that no matter where he is on the screen, because our screen is only 480 pixels across, he's always going to be at the far right edge or the far left edge when he's done that. So he's going to be pointing towards the controller, move to the left, and then he's going to flip around at the last second, turn 180 degrees. And that will get him pointed in the proper direction so that when he starts the level, it'll be at the edge of the screen, pointing towards the middle. Okay, so this part is good. Let's give it another little test here. So you see I've started the right-hand side of the screen. Our bad guys are still appearing like crazy here. We have to do some new code to make them appear according to the specs here. So we can't actually leave the level yet because we cannot kill off the last of the guys. They just keep on spawning here. All right, we're going to have to go in and modify a little bit of code inside our skeleton, and then we'll be good to go. And then when we kill off our last skeleton, our arrows will appear, and we'll be able to test our level changing system. So let's go have a look at that right now. All right, so we're going to go over to the skeleton. And in the skeleton here, so we've got this little bit of code underneath the green flag here. This ending part here, inside the forever loop, we're going to move all of this stuff. This is actually the enemy spawning that's happening every 6 seconds. We don't want that. We just want the number of enemies to appear that belong on that level. So we're going to just trash that, I think. Let's just delete this part here. And so this part with the green flag will just stay the way that it is, but we're going to add a new map changed event. And this is what's going to spawn our enemies here. So let's go ahead to our events. When I receive map changed, we're going to set our initial enemy count to 0. Set enemy count to 0. And that's going to tell it that there's no one there. Now, we're going to start making copies of ourselves. But if there are any existing guys on the screen here, we don't want them to make copies of themselves because they'll make infinite copies. Each clone will make even more clones of itself. We only want the original guy to make copies of himself. Fortunately, we've tagged that original guy with a variable called isClone that equals to 0. So all the new clones are going to have that variable set to 1. All right, so in a minute, we're going to be spawning our new skeletons, but we want to make sure that they're going to be spawned one at a time and placed kind of randomly on the map. I say kind of because there's going to be some parameters to make sure that they don't land too close to our player when when they get created. So as they're being created one at a time, we have to be careful not so that when we create our first clone, that we don't make our next clone be 4 clones, because our original guy and our clone are making clones. So we set up this variable called isClone, and that's an attribute that the master skeleton will have at 0 and the rest of the clones will have at 1. So we want to make sure there's only one clone being made at a time, because clones will copy themselves if you let them. That's something to be careful about. So if isClone is equal to 1, let's go grab an if statement and an equal sign and pop that in there. And we'll go to our variables, isClone. There we go. So if clone is equal to 0, so if it's not a clone, if it's a master skeleton that's making the clones, we're going to have them spawn. Now, first we have to wait for a player to spawn onto the screen and for our controller to be centered, because this is all going to be in reference to where other things are on the screen. And so if it tries to find its location first, it's going to get confused. So we're going to make it wait. It doesn't have to wait any real amount of time. We're actually going to say wait 0 seconds. And this is one of these weird Scratch hacks that you wouldn't have to do in a normal coding language, but it has to do with code precedence, which means what happens first if 2 things happen simultaneously. And Scratch kind of just does it at random. And what we want to do is make sure that this thing doesn't run first. And that's what the wait 0 seconds does, is it just puts it to the second in line instead of first in line for things to happen. So no matter what happens, this won't be the first block of code that runs. Okay, now we're going to go through a repeat loop here. We're going to repeat, this is still inside the if statement here, we're going to repeat the number of times of the number of enemies that we're going to have on the screen here. So we're going to say repeat skeleton count times. Now skeleton count, that variable is going to come from the map coordinates. You'll remember that one of the things that we set up inside our game controller here was a skeleton count for each level. You can see the first level has 0 skeletons, the second one has 1, and there's 6 here, and Jeffrey put in a goofy level here with 100. We're probably going to change that later, but I'll show you guys what that looks like later. That's map 2 by 2, so 2 to the right and 2 up. We'll have a look at that later and see what that does. It's really pretty hilarious. Okay, back to our skeleton. So we're going to wait skeleton count number of times, or sorry, it's skeleton count, which is our variable. And here's skeleton count. So repeat skeleton amount number of times. So we're going to have it run through once for each of the skeletons, and now we're going to place it into a random spawn on the map. So let's go to XY. Now we can't just use go to random position because we don't want it appearing in the sky, right? It has to appear within the playable area. So let's grab a go to XY coordinates block, and we'll tell it to go to the X coordinate that's a random number between the leftmost and the rightmost spot on the map. So we'll go pick random. Operators, pick random. So between the leftmost number, which is map limit left, and then map limit right. So we're just going to pick a random spot somewhere between the farthest right and the farthest left it can go. And we're going to do the same thing for the up, down. So I'm just going to make a duplicate of this random generator here. And we'll change this to map limit up and map limit down. So it's going to pick a random spot within the playable area. But again, we want to be careful to make sure that it doesn't spawn too close to our character here. So we're going to do a little bit of funny math here. We're going to change our X so that he's offset a little bit. We're going to change X coordinates by. Now here's where the math gets a bit weird. We need a minus sign and a multiplication sign. And the order of this is important. We're going to get into bed math again. So the minus sign goes inside the multiplication sign, and everything goes into the X here like this. So it's going to be the first part of the math, the inside of the bed mass equation. We're going to go subtraction first, and then the multiplication is going to happen after. It's like brackets here, right? So we're going to say x position, which is the x position of the skeleton. Let's go grab x position from our motion blocks. There it is, x position of the skeleton minus the player's x position. So we get that from our sensing blocks. That's the famous reporter block that I keep talking about. Let's pop that in there. We'll change it from stage to player, and it's x position of player. So our current x position of the skeleton minus the x position of the player. So let's say the skeleton's at 100 and we're at 50. That means he's going to be 50 to the left of us. So it's going to be 50 as a number that gets returned by that. So it's to the left of us, and then we're going to push him off the screen by multiplying it by a huge number. Jeffrey suggested 500 here, which is way more than we really need, but we needed it even if it was only one distant away to still be a big number. Okay, so that's going to push him over right off to the edge of the screen, but at a random height, I think. Or this is the part that's a little bit confusing to me. Let's go create a clone of myself right underneath here. We're going to test this out in a second and see where our new guys spawn, because I'm a little interested in this as well. All right, so I'd love to test this right now, but unfortunately, it looks like some other stuff still has to happen first. So when we start the game now, we're going to have the arrows appear. Let me show you. The arrows that are going to appear on the screen. We've got no bad guys on the map, though, because the first level by default has 0 bad guys on it, just to get you oriented with the game before we go. Now, to move to the next level, it's not just a matter of touching the arrow, but we have to touch the arrow and hit an action key, which is E, to stop us from accidentally changing levels when we're deking monsters. And we're not even allowed to change levels until we kill all the monsters in any event. So we have to enable the thing that will actually shift us to the correct map when we hit the letter E. So let's go ahead and program that. One last little bit to do inside our skeleton, and inside our arrows, and then we'll be good to go. So let's go to our arrows, and we're going to program a new event here that's just going to activate this new level for us. So let's go get a keyboard input. We're going to grab this one that says when space key pressed. We're going to modify it to say letter E. E is a nice convenient key because if you're doing WASD, it's right next to your up key in a really logical location. A lot of video games use E as an action key. All right, so we only want this to work if we're touching the player. So if the arrow is touching the player. So let's go to our senses, go touching player. So if the player is overlapping with the arrow, then we can go ahead and change levels. But we're just going to check here and make sure that this level actually exists. So let's do one last check here to make sure that the level attached to this arrow is actually existing on the map. Okay, so just to be safe here, we're going to do one last check to make sure that the map we're going to actually exists. So we're going to have a look at that list again that's called all backgrounds. We're going to use that block that says all backgrounds contains a thing, and we're going to fill up that bubble with something, and that's going to be the map goal, which is the attribute that's connected to that arrow key. So whatever that arrow block is, it has a map goal X and a map goal Y. So we're going to see if that map, in this case we're going to the right, so it's 1x0. We're going to see if 1x0 exists on that list that we've created down here in our list function under all backgrounds, right? It does in fact exist here, but we're going to check anyway. So let's go to, so we're going to join 3 things together here again. We're just looking for the title of that thing. So let's grab 2 join bubbles, put them together, and we're going to join map goal X, map goal Y, and an X in the middle. Map goal Y, there you are. There we go. So if background 1x0, for example, actually exists, then we're going to set our current map, which is map X and map Y. Oh, actually, we don't need those blocks. We're just going to grab a set variable. So we go set map goal, no, map X, sorry. Map X and map Y. And we're going to set it to our map goal, which is the attribute attached to that particular guy. So the right hand arrow is going to set, so map goal X on the right hand arrow is 1, map goal Y is 0, so map Y is going to end up 0, and we're going to end up at map 1, 0. So here's where we're going to switch our backdrop. We're going to go looks, switch backdrop to, and we're going to switch to a backdrop number, right? So the number is going to be, and we're just going to do a little trick here. So let's go to our variables. We're going to grab the block here under list that says item number. So this is going to return us the item number of where that thing appears on the list. And so we actually need this block here again that says join map goal X. Oh no, it's going to be map X and map Y. Let's just rebuild it from scratch here again, since we are in Scratch. Oh no, sorry. If item number of join and join, so it's map X. Let's go to our variables. We'll go there we go. So item number of map X. So in this case, let's go look at our list again, and oh, actually we just need to make it visible here. So 1, 0, which is our map to the right, is map number 2. So we're going to want this to add up to 2 at the end. Let's just double check and make sure. So item number of our current map, of the one we're touching in all backgrounds. Let's click on it, and that gives us a 1 right now. But we haven't. All right, to test whether this works, we have to change some of these variables around. So let's go set variable. We're going to set map X to 1. So we're going to assume that, so we're going to try to get the number 2 out of this. So if it says 1x0, map Y already equals 0, map X still equals 0 right now because we're on the main map. So if we change this to 1, let's go set map X to 1. The output here should be a 2 to tell us we're going to the second level. And there it is, the output of the 2. So if we change map Y, set map Y to 1. Now we're going to map coordinate 1x1, which 1x1 doesn't even exist, does it? So there's no place to go up on the map here. Let's go over to the next one over, which is 2x0 or 2x1 here. So let's set the map X to 2. So now our X is 2 and our Y is 1, which should bring us up to map 4. Let's click on this, and the answer is 4. So this is all working beautifully. Now let's just drop this into the backdrop. That will tell it which backdrop to go to. Okay, so fingers crossed. I think we're ready to give this a test. Let's hide this list. Let's maximize our screen. Click the start button. Okay, so no bad guys here. And oh, so there is a map that you can go up, but that's actually 0x1. We were looking at 1x1, right? Yeah. Okay. Let's go to the right. So we're going to go to the right hand arrow here. We're going to hit the E key, and we switch levels, and the bad guy appears. Excellent. Wow. Let's slash him. Now, our left and our right arrows have appeared. They should have been hidden. Let's try that one more time. We'll go to the right here, and the maps are appearing. The arrows are appearing right away. Something's going wrong. Let me just check on that. All right, so we did a little bug fixing there. It turns out the arrows were showing up because it didn't realize that there were enemies on the screen because that variable called enemy count hadn't been changed. So often when things go wrong inside a video game, it's because a variable isn't being changed the way we want it to. So one of the most important tools we have for debugging software is being able to track or trace how the variables change as the program progresses. So that's one of the reasons that we have this ability to view variables. Even if we don't need them in the actual playing of the game, sometimes we need them to bug test the game. So we're going to check this variable enemy count, and let me show you how this works. So let's go, we'll make it visible on the screen here and then try playing our game. So right now our enemy count is 0 because there's no bad guys on the screen. And you can see here that our enemies appear and our enemy count still stays at 0. So we know that's the source of the problem. That's why our arrows are appearing at the beginning of the game when they're not supposed to. So I went back and looked at my original code, and it turned out that I forgot to give you one of the instructions, which is change enemy count. We're going back to our skeleton, and inside the repeat skeleton count, we're going to tell it change enemy count by 1, and that's going to solve that problem for us. Now, one other issue that came up while I was double checking this is that the music wasn't playing. Now, that's another thing we had to double check. Let me turn off this enemy count here. Let's go back to the game controller here. So this is a little bit more of a complicated problem. The music is supposed to start playing only if there's only until there's no enemies left on the screen. And so again, it was thinking there was no enemies on the screen. Now this was because the music started playing before the enemies were actually spawned. Again, we're getting into code precedence, like which two win when there's a tie, right? And so the music has to happen after the spawning of the enemy. So again, we don't have to get it to wait for any real time. We just need to put a wait 0 seconds in here, and then our music will play. So let's give it one last test here and make sure everything works. Green flag, no music, and yes, arrows, because we have no bad guys. I'll go to the room to the right here, and there we go. Our music starts, and you can see we have one bad guy on the screen. I'll kill him, and as soon as he's dead, the arrows appear, telling us where we can go. Our only options are left or right, so let's go right here. I'll hit the E key, and now again, we got some bad guys appearing. It looks like they're all spawning to the right. I'm not sure if that's working randomly the way it's supposed to. Let's play a few more levels and we'll see what happens. We'll go up one here, and we're in our arena here. Ah, they're coming from two sides now, which is beautiful. So there's our random spawning in action. Beautiful, we killed these guys. Okay, looking good. We can only go up now. We're going to go to the dreaded level with 100 enemies in it. I guarantee you this is going to crash your game. You might want to just preemptively change that, but I'm just going to show you what it looks like just because it's kind of fun. All the bad guys, we rush towards them and kill like 50 of them at once. Slowly. There we go. Those guys are all dead. Let's keep going here. Nice. They're still coming. Oh my god, this is so slow. Wow. So if you just want to spawn massive bad guys, that's how you do it. Oh, one guy's left behind me. Let's turn around. The game is so laggy, I'm not sure if I have time to do all these things. There we go. He's dead. Turn around and face the last guys here. Come on, you can do it. Too laggy. There we go. One more time. Oh, just mowing down bad guys. Beautiful. Okay. And then our levels appear again. Let's go back to the left here. And it looks like we're on the moon now, where we've got one bad guy. And then I think we can go back home again. So we'll go over to the left here. And so this isn't the original map, or it's down here from one. So we're at, yeah, here we go. We'll go down, and I've lost it, but where we are now. Hold it. Down one more, so we were up 2. There we go. Now we're back on the original level with no bad guys, and it's looking good. So, mission accomplished so far. So you can see we've got the beginnings of a really good game here. It's the great thing about this gaming system we've created here is it's all infinitely expandable. You can put your own characters in it very easily. You can create your own maps now. Create very complicated map networks where you can go off in any direction, and it'll only let you go places where you've created real maps. So it's really expandable. You can use any background, as you can see. All you have to do is grab any background, then define the area with X, Y coordinates where you're allowed to play in. You'll spawn into that area. The bad guys will automatically spawn into that area, and the arrows will point you to where you can go from there. So it's a really nice little system that we've got here. I'm really looking forward to finishing this off with you guys. Next week I'm going to be doing doors and keys and items and stuff like that. So we're going to look into being able to pick up items and stuff in the game. And then I think we're going to add a new baddie in week 5. And then we're going to end off our series, I think, in part 6 by making a big bad boss for you guys to fight. So everything's coming along really well, and I'm excited about finishing this with you guys. So I look forward to it. We'll see you guys next week. Remember, I'm live streaming every Saturday morning at 10 a.m. Eastern with a fun little show. It's more relaxed, just live streaming, call in and talk to me on Discord, and you can see get some Scratch tips, remix some games, have a look at some student-made projects, and just a fun place where we hang out and talk about Scratch stuff. So please join us there if you like. Otherwise, I will be back with part 4 next week. Thanks, guys. Bye now.